Okay, so data centers, no secret, they're already under a fair amount of pressure in terms of the amount of energy they use, quite a high profile in the media, etc. But in fairness, they are already making a reasonable amount of progress. So perhaps be good to start with how you would assess, sort of where the data centers are on their journey towards their, sustainability.
So, Phil, it seems to me like a big challenge in general for the data center, but also a great opportunity for customers and their data centers. Because as you mentioned, like currently enterprises are struggling very frequently with power constraints, plus rising energy costs. So there's a lot of pressure in the system. Plus, then it comes AI and all of the respective compute requirements for this workload in particular. So if you add all the things into the mix, I think part of the problem which enterprises and cloud services and cloud providers alike pretty much have been seeing on the market is also coming from the perspective of stretching the IT refresh cycles. So a lot of customers, change the traditional 3 to 5 years refresh cycles to 5, 7. So this is done to maximize OpEx and cut costs, but the replacement timelines themselves do not really contribute very well enough to sustainability. So what I mean by the opportunity and the challenge, sorry, especially by the opportunity, is the opportunity specifically to refresh the current installation of hardware and optimize what is used now, because there are different technologies available on the market to do so in a better way. So to me, yes, there has been a progress, but I think it's important to keep in mind the continuous improvement we need to deliver in this space for the years to come.
Okay, yeah. So there's an opportunity there, but you mentioned in your answer AI, and potentially the problem's maybe going to get worse before it gets better, because there's this AI explosion predicted and already beginning to happen, I guess. So that's going to add, high performance computing is going to expand exponentially, whatever, over the next few years. So that's a further challenge, as it were, to the industry when it's already, I would say it's made progress, but there are clearly existing challenges. And then there's this new AI shaped challenge as well. So yeah, just your thoughts as to how much more of a problem that could create.
Problem. Well, I think generally speaking, bringing AI to the data center and the compute and energy requirements from the AI does possess quite a significant challenge to the data center. However, this is where exactly server consolidation comes in from our perspective. So an enterprise, even right now, currently, like your traditional data center, whatever it's like the large installation or even the smaller ones, like the SMB customer, they could go and leverage the currently existing, the best-in-class products and drive this consolidation from a perspective of you need now less machines to run the same type of workload you used to, or the you're planning, let's say, to run in your data center. So with that being said, we have customers who are able to do such consolidation with AMD EPYC, which is my flagship product, but regardless, that's my coverage. That's where I feel most of the passion and interest, to be very frank. But we have examples, as mentioned, like customers driving 15 servers, old ones, to 3. And only this move leaves enough power actually for the customer to add a separate AI server into your rack. So we don't talk not just about having the new technology and adopting AI in their data center, but also doing what they've done previously in a better and more sustainable way. Or you can say in a better, more energy efficient way. And we have other examples and numbers, of course, and they differ from customer to particular requirements, but it can be everywhere from 17 to 11, 5 to 1, 11 to 6. Like it really depends on particular requirements. But freeing the space and energy used for traditional applications in the current data center, in the current installation, to then adopt new technology and push the envelope further, That's possible right now. So it's more like a complicated question on how you can do it in the best way possible. And I think we provide great technology to do so already now.
Okay, and in terms of the way the efficient use of energy, power, the data is measured, PUE is the metric that's commonly used. And I guess if you talk to a data center facilities person, they would explain how well they've done in reducing the PUE, over the last few years, and might fairly or otherwise, I would say, point the finger and say, well, while we've done this, the IT hardware hasn't perhaps mirrored our rate of progress. I mean, is that a fair criticism? And is it, whether or not that's a fair criticism, is it time to maybe focus more on the IT hardware as to the opportunities to increase the energy efficiency of the technology there?
Bill, it's definitely a great time to focus on the IT hardware aspects. With that being said, though, in ideal scenario, you need to focus on everything, right? So on both the IT hardware and compute aspects, as well as facilities, but also expanding it further into, where you source your energy from, how you deal with heat post-processing. Like all of this stuff is extremely important when it comes to sustainable data center and generally for our future, right? Like the compute requirements are constantly expanding. The data we generate and process is constantly expanding. So we need technically more compute capacity, but leveraging what you have out of those calculations, which is again, usually in the closed loop cooling solutions, is excess heat, is extremely important consideration, because otherwise, well, it's going downhill, right? So if we don't think about all of the incoming resources and outcoming whatever, like CO2 emissions or any other relative energy required to then post-process any type of heat or other outcomes, or even like water circulation, right, in the closed liquid-cooled system. Like if we don't think about it, engaging in the conversation of driving the compute and hardware aspects into a sustainable way, yes, it will be impactful for sure, but it will not paint the big picture and like the closed loop picture. So I mentioned it already. I think it's extremely important to remind every time that the continuous improvement to take steps in both ways is required. And I actually would like to give one particular example. It's our great partner Lumi, because this will resonate and paint the whole picture, I believe. So it's not just the Europe's fastest supercomputer. So it's based in Finland. So it's Lumi, and it's based on the top 500 list from November last year. So relative recent, right? And they actually use 100% carbon-free hydroelectric energy for their operations. But plus, the waste heat is reused then to heat up surrounding areas and houses. Like, so this is real talk and real picture of, having not just the best compute performance and like compute capacity, but also using the outcomes of that for the greater good. And I think that this is exactly the potential for making more green data centers and a better approach for the future.
Okay, and in terms of the IT hardware, as that example you've given, Bruce, AMD, you've obviously very much focused on improving, shall we say, the energy efficiency of the compute side of things. I'm just be interested in the types of things you're doing. And I know, for example, architectural innovation is one of the areas which you're involved. So perhaps you can expand a little bit on that, what the type of activity, obviously without giving away any trade secrets, shall we say, but the types of activity you're looking at in that area.
For sure. There are many things to share, actually. And I think the title would be that we strive to give the most compute at the lowest power. And to address the diverse requirements of the current data center and also the data center of tomorrow, we actually have a number of separate architectures, which we combine from time to time to deliver the best outcome for particular use case and like product possible. So we created 4 architectures some time ago, and it's different story of every one of them. But like to give you a high-level perspective. So our Zen architecture spans across EPYC and Ryzen processors. So this is what we usually drive as the most energy efficient x86 processor on the market. Now, on the other end of the spectrum, we have also CDNA architecture. This is what we use in our AMD Instinct accelerators, so the large language model training, inference, like your traditional data center GPU. And this particular architecture delivers the highest performance to the industry, and it also powers the world's fastest supercomputers, for example, Lumi, I mentioned already, right? And this is exciting, but on top of that, we have RDNA architecture, which is the core of our Radeon GPUs. So it's just featuring number of AI accelerators and can be used actually at home to do Gen AI right now. So with the ROCm support, the software stack we actually transforming not just the gaming experience, which is the usual market for this product, but also the even like workstation edge type of experience you might have. And again, you can run AI models for inference right now on the GPU in your workstation, like, or in your desktop at home. And I know we're talking more about data center, obviously. So we have the fourth architecture, which is XDNA. And that's going into a bit more technical details, that generally an NPU architecture, and that's very much focused on AI engine and AI engine processors. So it has a particular set of features and particular logic to process those calculations in the most energy efficient way possible. So it enables you low power computing for AI and signal processing, but also uses different technologies like on-chip memory, custom data flow to enable this energy efficiency. And we have this architectures presented across the portfolio of the products we have. And as we touched upon AI specifically, we actually have the broadest portfolio in the market, from traditional, server GPUs, so data center GPUs, to data center CPUs, to FPGAs and special accelerators, to even like Ryzen AI, our laptop AI engine, like which is powered traditionally laptop experience. So we have been driving the industry in multiple ways in terms of the innovation, for example, of the chiplet design. But we can talk about it more later on if the time allows us to do so. But it's just an exciting, really exciting portfolio and really exciting time to leverage those special architectures for particular use cases, like not one size fits all, but really finding the proper, the most utilization out of your compute unit. And I think it's extremely exciting part to be part of the AMD.
Okay, and alongside that, what you've explained when it comes to the architecture, I think perhaps with mentioning the chiplets, we go on to this, the packaging advances. So it'd be good to understand what it is you're doing there. I know that sort of, was it 2.5 and 3D architectures, designs are becoming more mainstream, but just, what it is you yourselves are doing around packaging.
So I mentioned the Zen architecture for our CPU. So that's the product I cover, and I can show it to you as well if that's of interest to you and also to your viewers. But basically, this is our 4th generation AMD EPYC chip. So it goes up to 128 cores. So it has a lot of core density per unit. And what you see here is 12 smaller chiplets where cores reside, and also the I/O die, where all of the I/O memory channels and all of that reside. So we also have security features and security engine, which is embedded in the I/O die as well. But I don't want to talk more about this like technical details. What I wanted to show with this in particular is that we have been actually implementing this type of chiplet architecture and design for over the last 6 years. So this is the journey with AMD EPYC and our Zen core architecture. And when we initially started to develop it, there were 3 main goals. It's the ultimate performance, the ultimate scalability, and the ultimate efficiency. So having this, the best compute at the lowest power in mind. And by leveraging the leadership manufacturing processes we have on the market, in general with our partners, and innovative design which we bring, we were actually able to bring this, like 6-7 years ago, pretty radical idea of chiplets for x86 processors to the market. And now with this, we have over 300 different world records across many, many benchmarks and workloads, including, of course, energy efficiency and virtualization performance and HPC performance, whatever you really want. And many customer success stories adopting this technology. So in really, I would say, easy terms, what it enables us to do is to build the product in a way and using the technologies we want, which addresses particular needs at the time or customer needs specifically. So we can mix and match technologies, add the engine here, remove it, add something else, have more optimized, let's say, performance per particular space, which also goes into performance per watt perspective. So we have different product lines for that, from our 9000 series, 8000 series to 7000 series and so on. And this is, I think, from the packaging specifically and from manufacturing process, is what we see pretty accelerating on the market with also other parties and our other manufacturers in the world. So the last thing I think to mention on the packaging specifically is it's such an incredible achievement, and it's such an incredible product. And we have seen over the last, let's say, four generations, because we talk a lot right now today, Phil, with you about energy efficiency. We saw not just traditional, now you have more performance with more power type of scenario, but also increasing gen over gen, the performance per watt. So within the same core count, within the same power envelope, within the same space, we can go and increase the number of cores, or we can increase the performance per core. And that's something which I think really resonates with the market. So those packaging technologies, you mentioned the 3D, for example, 3D stacking, we also use on top of the chiplets. So in our Gen X products, for example, we use 3D stacking for cache, increasing amount of cache. So it's usually very beneficial for technical compute, HPC, CIE, CFD workloads. So there's a lot going on, and that's just the CPU, like the EPYC Zen architecture. It's just really, really exciting product. I mean, you can most probably tell very easily that I'm very, very excited about that.
Yeah, and maybe to sort of complete the picture, I think there's also quite a lot of work goes on around the algorithm. So algorithmic improvements, I think, is how you classify it. So again, if you can just share what kind of work you've been up to.
So in general, every new product generation, we strive to push the envelope further. And it can be optimizing the microarchitecture, code, data paths, whatever it is. But while we supply the chips, right, and produce them, not always we as AMD can directly impact the code which is out there in the world. Because I think algorithmic improvements very frequently lie in the code itself and all the programmers out there in the market. So one of the examples is there's a lot of debate wherever the performance of the, again, AI thing, of the large language models over the years is influenced more with increasing computational power or by the algorithmic improvements specifically. And from what I have seen, it's both. So what's exciting, though, is coming back to the product perspective, what we do, and also about the industry, is utilizing the most energy efficient and high performance products, such as we have with Zen architecture or CDNA, RDNA, and so on, and then actually create better products of tomorrow. So imagine using AI to write better and more optimized code, the usual use case actually from ChatGPT and some other vendors. So this will generate even further algorithmic improvements. And plus, on top of products, we actually strongly support open source ecosystem and community. So having this best practice exchange and even further, like more algorithmic improvements on the market makes it even more exciting to see how the next generation of developers and code itself will change. And so once again, doing the products, optimizing it, making the best, performance or the best computational power per the power or electricity available. So we drive the ecosystem further to enable more best practice sharing, then further to the market. It's exciting time and really is incredibly interesting on how this will all develop in the future. So I think we will see more of that in the years to come.
Yeah, and mentioning what's to come in the future, and early in the conversation, you talked a little bit about liquid cooling. So that's another technology that I guess it has been, as people remind, it was used way back when on mainframes. So it's not, brand new technology, but it's kind of having a second coming, but it looks like it's going to, get some significant traction. So just your thoughts. So I suppose it kind of crosses over both the IT hardware folks and the facilities folks. Just your thoughts as to is there an obvious winning technology, because there are different approaches to liquid cooling, and just what it is AMD is doing? Are you working with some of these solutions? Just anything you can share as to liquid cooling and yourselves.
Sure. You mentioned that it's a challenge or opportunity for both facilities and an IT problem and solution as well. And I strongly believe that is correct. So it's both. There are frequently space and location in like the space restrictions sometimes to adopt those type of technologies in the current data center. And we talk not just about like liquid cooling solutions, but also expanding it further to immersion cooling, for example. So with that being said, it's still a great opportunity and even potentially a path forward, because we see a lot of that happening on the market from different partners and from different parties. So like generically adoption seems to be picking up quite rapidly. So we, as of right now, have many partners offering various types of cooling solutions, right? So including the DLC, including immersion cooling, and we have success stories of deployment of those solutions in the data center and the outcomes which you can achieve with that. So I really like examples, usually like, customer quotes or really quotes from end users and what they have been able to achieve. So one of the recent stories we have is actually with Shell, and in their US-based HPC cluster data center, however you want to name it, they're using our 4th gen AMD EPYC processors, the ones I showed you, like the chiplet design, but they use it with immersion cooling. So it's with our partner Penguin, and they actually boost the performance while also, supporting business and sustainability goals at the same time. So fun enough, fun, like even further fun story and fun fact is that their Houston data center already draws 100% renewable power. So that's one of the things from cooling perspective, like an example, not DLC, like you asked about this. I think DLC, liquid cooling in particular, you can see it in Lumi as well, and a bunch of other partners. So there's many data centers currently using this technology. And my guess it will be picking up, considering all the sustainability goals from the enterprise customers and all of the other trends in the world happening. So, but you're right. So we are supporting the ecosystem to actually qualify and deliver those solutions based on AMD hardware while still focusing on hardware aspects, right? For it to be designed the way that it's mostly energy efficient, or that was not the correct wording, not mostly energy efficient, but it's energy efficient by design. So you get most out of it.
Okay. And in terms of the sort of success, the results you have, you've obviously been sharing some examples, but it seems as if would be fair to say that partnering with other organizations is one of the main ways of developing more energy efficient technology. So it'd be good to understand any other sort of key partnerships you might have in that area. And also, yeah, as you've already done, I don't know if there were any other sort of end user examples which illustrate particularly well, what it is you're achieving when it comes to power efficient processing, which I guess is the ultimate goal.
It is, and I can definitely share more for sure because it's extremely exciting. One thing on one hand side, we have different type of platforms and cooling solutions from the OEM and ODMs platforms and partners. Like it's hard to mention them all, but the likes of Dell, HP, Lenovo, and others, same as Supermicro, Gigabyte, Taiwan, and others. Like there's just a lot of this happening throughout the ecosystem. And I think you rightfully mentioned that partnering with ecosystem and partnering with different third parties is the way to go, because you cannot like design and construct everything yourself. Very frequently, you need those partners to enable the competition on the market, but also the innovation on the market. So while on one hand, we have different platforms and different solutions already available, on the other hand, we have those solutions being adopted. And as of the latest top 500 list from the HPC perspective, I'll give both the HPC as well as some enterprise customers examples. I think it's important to see the whole picture and different things you can do with products and technologies. So as of right now, we as AMD, we power 8 out of top 10 most energy efficient supercomputers in the world, including the #1 supercomputer. So that's based on November's top 500 list. I already mentioned Lumi a number of times. So a couple of other examples. I think HPC-wise, KTH, University in Sweden, they achieved, numbering correctly, I think about 6 times as much overall performance for comparable overall power consumption in their refresh, like in their HPC cluster refresh with AMD. So on top of that, in the enterprise space, we have the recent case study, success story with ST Microelectronics or ST Micro. So they could, with the help of AMD EPYC, actually drive a 1/3 reduction in electricity consumption for their own production. So that's better performance, better value per core, at the same time as better, business objectives for the company. So it's extremely exciting. And another recent story was with DAR. They are in the Middle East. And they were able to unlock 3 times or even 5 times faster performance with actually 50% smaller server footprint. So considering that and considering the consolidation aspects I've mentioned a number of times, like this is exactly what we deliver as of right now. And we strive in it, right? It's a server consolidation aspect, and getting the most out of the space you have is what we really want to drive further with AMD. And on top of that, we actually, together with some of our different partners, we created, not for data center, but for data center as well, but I have a couple of other examples too. We created a modular design for laptops and desktops to provide better upgradability, like the CPU refresh. So we also launched different regional trade-in and upgrade partner programs with our partners. So, and we enable and support qualification of different types of liquid cooling and immersion cooling solutions with our partners on the market, locally, globally, really everywhere. So I hope this helps to paint the bigger picture of what we've been doing as AMD.
Yeah, and I guess you mentioned sort of some HPC examples, but I'm just wondering as well, this AI explosion that's beginning to happen, I guess, are you also already engaging, because clearly the AI training models require a fairly sizable amount of compute resource, shall we say, and therefore there's an opportunity to bring in energy efficiency there. Is it too early to be having success stories, or are you already having an impact there when it comes to these large language models?
We do have already impact there. So we have a corporate goal, which is 20 to 25. It's called so. And the goal is to deliver a 30x increase in energy efficiency for AMD processors and accelerators powering specifically HPC and AI. So our goal technically equates to around 97% reduction in energy use per computation. And as of mid-2023 or end of 2023, when we launched our new set of data center GPUs, we're actually on track toward achieving this improvement. And I think we are on 13.5x mark already. And so if you look into deploying really at scale, so enterprise customers are very frequently looking for all of the possible outcomes, right? So optimizing power, optimizing space, optimizing CapEx and OpEx. So there's very sensitive balance of all of those elements. And taking into consideration example of the data center GPUs we have with MI300X, we can actually enable customers currently to run more models or larger models when it comes to training, utilizing higher memory capacity and bandwidth, which we designed in the product. So this translates directly into lower CapEx and other business benefits. But that's just one example of the product perspective, right? So in general, we have this on top of our mind. So energy efficiency and really reduction in energy use per computation is a guiding principle of how we design products and push the envelope further.
Okay, and then in terms of summarizing all of one final question, a more general one. Clearly, the whole world is digital now and continues to advance down that path, but we're also very much focused on being sustainable. And as I often ask a lot of the people I chat to, do you have a view as to whether those two things are entirely compatible so we can be digital and sustainable? Or at some stage, do we have to make an element of compromise and say, okay, we're going to be fully digital, but that means we might not quite get to net zero, or we might not get there by 2050, or take it the other way. If we're going to be truly sustainable, then we have to look at somehow limiting, the amount of IT resource we are happy to use, which is obviously quite a complicated thing to do. But just your thoughts, I guess, as to how compatible are digital and sustainable.
I think it's a very fair question to ask. And as you can, I guess, see from our conversation, I prefer to be optimistic on that note as well. I'm not dire in this perspective, right? And the examples which I actually provided previously, to my perspective, paint a world of possibilities. So there is a great opportunity today to review what is currently running, what is currently in production, as frequently a lot of the space which we currently use for computation or for digital services, it might actually be used by old and sometimes inefficient equipment. So replacing all the systems now with new ones, it brings not just the performance to the data center, but also can use less space and power to achieve this performance. So coming back to your question, right? We talk then not just about satisfying the demands of the world and of the IT and the digital space, but also using, well, physically less resources to do so. And then we have actually great and free TCO tools on our website to help calculate different scenarios and savings, like potential savings. So I can highly recommend them both to you and your readers to check out for yourself. It's really easy tools and like fun to play with. But on top of that, there are new and sometimes more efficient ways simply to run different workloads, right? So if we change the perspective of being, very focused on the way we traditionally ran data centers and traditionally use the technologies to more like adopting new things which are available on the market and even testing it further. So it enables us to more efficiently run workloads, whether it's through dedicated hardware acceleration or software. I mean, we have examples with a floating CPU load to DPU or Smart NICs with AMD Pensando, or using FPGAs and other specifically or specially tuned for special workloads accelerators. It just brings you faster and more energy efficient way to run some of the workloads. So it actually contributes to sustainability goals and our, power hungry world from the energy efficiency perspective. There are things currently we can do, not just in the future, to make it better, right? So to run more efficient workloads, to have a better performance per watt perspective, let's say, out of your whole compute infrastructure. So I think the world we currently live in is, like, from the data center perspective, is not 100% ideal. There are always ways to improve ourselves and adopt new technologies, but I see it as more an opportunity for the future to make things better and learn from what we currently use and accelerate the adoption of new technologies in the data center, collocations, whatever you want to use that. And we talked a lot about AI, so freeing some space for AI in the data center using the last technologies. We talked more about the liquid cooling or different cooling technologies, so trying out those to make it like better from the PoE perspective, is also offsetting heating costs and some other elements, even like from economical perspective. So I think we can get there. So how much time it will require, that's an open question, but I think there's a lot of progress on the market already, and it will be accelerating in the future.
Okay, I mean, it's been great to chat, and some brilliant thoughts and insights as to what's going on, shall we say, in the data center overall and at AMD specifically. So, Alexander, really appreciate your time. Thank you very much.
Well, appreciate your time, Phil, and thanks for having me.
Thanks again.